Imagine a world where you can design molecules based on certain criteria on a computer. Precisely this was the topic of my project. This project was based on my personal curiosity on the topic of computation. I asked myself the question, what are the limitations of computation in science in terms of accuracy? After doing some research, I realized that depending on the model, it either requires a lot of computational power or it isn't accurate. Based on some research and what we learned in school, I asked myself whether there are models for chemical phenomena similar to the models for physical phenomena. Models for chemical phenomena already exist. Density functional theory can be used to calculate the distribution of electrons in molecules up to very accurate degrees. But density functional theory requires extensive computational power. Are there any more efficient methods? This last question led me to the topic of this project, prediction of molecular properties using deep tensor neural networks. The goal of this contribution was the computation of a neural network for the prediction of the molecular properties, dipole moment, polarizability, and internal energy. This project is just a small cog in an effort that spans many different disciplines and industries with the ultimate goal of designing molecules based on certain criteria. Before diving into the predictive model itself, I still need to address the elephant in the room. How is it possible to describe a molecule using numbers that can be processed by a mathematical model? In my project, I used the Coulomb matrix to represent the molecules in a numerical manner that can be fed into a mathematical model. In this project, I used the deep tensor neural network to model the molecular properties. This is the structure of the deep tensor neural network. Before training the model, I had to find the optimal hyperparameters, so I trained several models over a smaller dataset to find the lowest mean absolute error. Then I trained the model for several epochs to check its convergence behavior. Finally, I trained the last model over the whole dataset. This graph shows the convergence behavior of the model when trained over the whole dataset. Thank you for your attention.